Hello and welcome everybody to this next installment of the laboratory software review. You already know who this is, it's Laz. And today in this instance we're going to be checking out grain size distribution or particle size analysis. There's so many different names and ways on how you can call it, but before I even start talking my head off about this, we're just going to get right into it. So let me log in and might get a little loud. Everything's at risk. Okay, actually, don't really need that open. All right. So with the last videos we've seen, I wouldn't say putz around, but I fussed around with things and whatnot. Where I did already install the grain size analysis or grain size distribution. So just kind of talking about it a little bit, a grain size analysis or distribution, or however you may want to call it, because there's so many different names that you could call this, and there's no right or wrong way of calling it. It's to determine your particle size of the composition of your soils and or aggregates, and it also helps define where it goes on the classification table, depending on which classification type that you're looking for, simply put. So let's open up the program here. Oh geez, it's going to do this weird thing again, isn't it? When I really thought that I'm going to be doing something else. Whoops, sorry, I lost my train of thought. I thought I fixed this from the last time, but I guess not. My resolution, what the hell is going on here? Good Lord. I know, it's always something, right? Alright, let's check out display here. That. Yeah, I ain't recording from there. Nope, just displays just those settings. Scale factor, all monitors, 3D. Well, it's up to there, but then that's kind of weird. Okay, well, I guess we're just going to do this the wrong way. Yeah, because I don't have any settings whatsoever. I think even if I minimize it, yeah, that makes it worse. Cool, right? Blarg. Okay, hold on. Now I'm going to have to mess with the graphical settings. I know, we're off to a great start, right? That's just how this usually goes. But it's okay. That's why I wouldn't say I don't care how it goes, but that's kind of the fun of it, you know. Not like any of my other videos were ever perfect anyway. Alright, so we'll wait for this thing to shut down, because it's really weird, because I thought I fixed that issue from the last video, but I don't have like any kind of adjustment settings in the window itself. So let's see if I change some of the settings. No, give me expert. Yeah, that's kind of whatever. I guess I'll scale it down to 100 for now. Yeah. We'll see if that might help. I know it'll kind of distort things, but yeah, something's up with the Tool settings. Alright, anyways. I know, I'm just looking around too much. Anyways, let's power this bad boy up. Let's see how it's going to look. Since I had it zoomed in at 150% the last time. But I really thought I fixed that issue. Because that needs to be fixed so we can access, you know, what we're going to be doing. Technically. Preferably. Okay. It's trying to power up the VM. I broke it, oh boy. I know, we're really off to a good start, huh? I'm definitely going to be annoyed if this is going to be foreshadowing like the first 30 minutes of the video. It's just going to be me trying to make this thing work, even though it's working just fine. Okay, are you going to power up the VM maybe? What is going on here? Actually, I think I dealt with this before. I think I'm going to have to pause the recording here real quick. Okay, I'm back. I don't know if I fixed anything or not. I mean, it still looks about the same, honestly, which I'm not shocked, honestly. Yeah, I know. What happened to AOL? I don't know. Guess America just isn't online anymore. I hope it's... I don't know, maybe I won't have to worry about that. Maybe I won't. But anyways, let's open up our project and let's get Blaz loaded up and hopefully this will work. I think it will. I think I was just probably having flashbacks or something from when I first started. Because I mean, of course this is going to be a low resolution because this is like not 100% DOS based, but you know, it is to an extent. Sorry, need a sip of tea. Alright, so we're just going to get back to our boring that we started before, you know, sample B1 at the depth of 0 to 2 feet. And now we're going to enter in our grain size distribution. Okay. So we're going to do some extra fancy stuff while we're here. On top of that, we're going to create a, I think we'll create a sieve spec, perhaps. I know for sure we're definitely going to have a specification set, and I'm going to explain all that in a little bit here. Alright, we will put, oh yeah, that's right, this thing's weird, because you can type it here and it does it there. Oh my god. DOS stuff. It's weird. Well, legacy DOS stuff. This isn't fully DOS, obviously. So, I don't know, we'll put today's date. Put today's date, and of course, since we're still in the same boring and whatnot, it still keeps all of our data from before. So this was our Atterberg limits that we covered before, and this is the classification from that. Granted, this time around, the classification portion is going to be modified a little bit. I might cover over a hydrometer. I don't really know, honestly, if I want to or not on this. But I might. It's a big might, because I'm going to need calibration data, and I don't think I have that handy, technically. Okay, so mechanical analysis performed, mechanical data calculated. That's a weird checkbox. use cumulative basis. Yes, we do want cumulative basis, and I'll explain more of that as we go on. So, all right, so I think what we're going to do is that's weird. So for the hydrometer separation sieve, you have 40, 100, 200, and 230. Maybe that's what's part of the old spec, because technically, currently, if you do a hydrometer, you either separate over the number 4 sieve or the number 10 sieve. It's up to the technician to pick. I usually do the number 10. Yeah, your minimal gravel size, which really technically your gravel size should be number 4 and greater, because anything on the number 10 is technically coarse sand. Material larger than gravel is cobbles. It's kind of up to you however you would want to do that here and whatnot. If you want to say anything that's greater than 3 inches or anything that's greater than plus 75 millimeters. Wow, this can do 270. Let's see. Clan divisions. This is if we did enter in a hydrometer, which is, like I said, I'm on the fence for that one. That one I'm not too sure. Your curve type is a mathematical formula. If you do a hydrometer, it's more hydrometer stuff. Because really, the sieve analysis itself is a really simple and straightforward process. Auto shaping, I think, makes the curve look more cleaner. We might play around with that once when I get some data in there, just to see what it really does. Report coarse, medium, and or fine gravel sand. Yes or no? Yeah, but I will say, even though I'm going to say to report this for the sample I'm going to put in, it's really, I mean, as you can see, it's going to be clay, so there ain't too many particles in this. So at least for the example I'm going to be using, I don't know if I'll find a different example to use. I guess that'll be something that I'll think about. Alright, mechanical sieve sets. So let's check this out here. Demo project sieve, aggregate sieve. Okay, perfect. Uniform. So ASTM D422 is your hydrometer analysis, or your particle size analysis of soils using a hydrometer. Technically, this day and age, this specification has been discontinued and has been replaced by 2 other specifications that I can't name off the top of my head, because technically our facility doesn't do that. We do perform AASHTO's T88, which is almost the exact same step-by-step thing as an ASTM D422, but at least as of this time of the recording, there's still plenty of engineers that still like using ASTM D422, even though it's a discontinued specification, because it's an easier reporting format. Unlike for what the hydrometer has turned into, you have it pretty much split up into 2 specifications, where you have your hydrometer test itself, and then the other one is a sieve analysis of the soil itself, which I think they only came up with that because technically there really wasn't a sieve analysis of soils. You had it for aggregates and asphalt and things like that. And there technically really wasn't one, unless if you did a hydrometer. So that's why a lot of people would just say, hey, I want to do an ASTM D422 without the hydrometer. So a hydrometer without a hydrometer test, which technically what I'm going to be inputting in today is going to follow that exact same moniker for this proficiency sample that I did. Okay, so anyways, let's create a new sieve stack, shall we? So let's say new. Yes, I do. What? Found a path access error. And then it sort of crashed. Interesting. Because I don't think it's going to let me Maybe it'll let me do it here, technically. Let's see. Oh, yeah, kind of will. What the hell's going on? Oh, there we go. Alright. Yes. That's so weird. Why is there a file under path access error? Hold on, let's check out general setup options. Program path. Complete program path of Geosystem long draft program. Log draft program. I wonder if that's a specific component. I feel like that's a specific component. Because with newer versions of Geosystems, you can set up a path where everything can save and whatnot, but hold on, let me see here. Here's Geosys. Just kind of curious. So there's our project itself. That's weird if it wouldn't want to save here. It may not want to, so I think I'll try putting in a path. Actually, wait. Let me go back to here and it shouldn't matter if it's all here. I'll just take it to the directory itself. I wonder if that's the issue that's going on here. I wonder if that's what's going on here. I mean, I can modify one of these, but it makes it better if I can make a new one. You know what I mean? Nope. Wow. Well, this version almost kind of sucks. I think I might have to just modify one. I guess I'm going to have to. Here's an aggregate sieve set. Oh, thanks, Rio. Yeah, we'll just modify this then. I don't know. Oh, that's weird because it usually never has an issue with that. So we'll just call this soils. Change that to soils, and then we're going to change our sieve sizes here. So, and this might have, well, actually no, it won't have everything because this is aggregate. So I'll have the 1.5, the 1 inch, the 3/4 inch. I don't really need that one. Oh, damn, am I really going to have to like reorder all these? I think I'm going to have to reorder all these. Interesting. Whoops. Alright, so number 4, number 10, number 20 sieve, number 40, 60, 100, 140, and then 200. Okay. Yeah, because there really isn't anything new there. Wow, no save button or anything. I guess I could just hit... Oh, there's a delete one. Okay, never mind. As you can see, I can't... Wow, it's just not going to let me do anything. Wow, I wonder what the problem is, why it doesn't want to do that. Very interesting. Yeah, both of these would be great. Applies only to the project created after this time. Okay, that makes sense. Huh. That is very, 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 very weird. Okay, you know what? I'm wondering. I'll just say save and exit. And I just want to get back to the main page again. I'm wondering if it's because I'm in a project file. I don't think that's going to matter. Hey, look, it actually saved it. I wonder if that's why that was happening. Let me create a new one. Nope. Still won't. So there's something wrong with that where it won't let me modify a sieve stack, which technically isn't going to be the end of the world, because typically with this program you can pick a set sieve stack if you want to. It's just it makes it a lot easier if you already have that established, so you're not typing things in. But I mean, who cares if I have to work more, right? I mean, all right. Anyways, all right. So 8, 23, 25. I don't have any testing remarks, so that's kind of weird how there's mechanical analysis performed. Can't even really see the Y. Looks like a B. Because technically for sieve analysis you can hand sieve it. It's just it really sucks to hand sieve it for the most part. So that's kind of weird why that's an option, and we'll mess with that slider later on. So I'm wondering if this will actually let me create specifications, which I don't really have one off the top of my head. I'd have to look up one, and I don't know if I want to be bothered to do anything like that. So technically a sieve specification, or what some people will call an envelope, your specification envelope, is whatever size particles, regardless of whatever stack of sieves that you do use, must have these in here, and your material must be within these requirements. So if I pick this ASTM D44886, which the 86 afterwards means the specification year, so this was 1986, and this is size 1, so more than likely this specification, because I might have worked with this specification, but I can't really remember if I personally have worked with this. So if we look here real quick, so I'll kind of cover the sizes in a little bit. So if we look at this here, for this is saying here's your sieve sizes here. It's a little bit deceiving because it doesn't indicate inches, but it's definitely in inches, I can tell you that. You can have it set to millimeters. I know the new one you can have set to millimeters if you want. I don't know if this one will be weird about that. But anyways, so as you can see here, so for this specific size of aggregate, because this is specifically for aggregates, so rocks. So if I say aggregates, that's the terminology, is rocks. And rocks are exactly what they are, they're rocks. So for here it's saying anything that's 4 inches, so a 4-inch size rock, needs to be 100% passing. Your lower and your upper limit. Your lower limit is the amount of material that can be retained on the sieve, but it can't be any less than that. Your upper limit is your maximum. So you can't have a material any greater than that retained on your sieve. So that's the whole idea of your upper and lower limits. So for this specification here, it's saying you need 100%, like 100% needs to pass a 4-inch sieve. And then you get to your 3.5-inch sieve. So you can have 100% passing or 90% passing your 3.5-inch sieve, your 2.5-inch sieve. You have 25% passing to 60%. Your 1.5 sieve is indicating you can have nothing passing, but nothing great, or everything passing, not nothing passing, everything, no. Oh, good Lord. Sorry, brain fart. 100% passing means everything's passing. So you can have everything retained, or you can have 15% still passing, and then your 0.75 inch sieve, you can have everything retained up to 5% passing. And that's how sieve envelopes work, or specification sets. So getting back over here, so if we look at these sizes, and the sizes are very, very deceiving, and I'm not going to lie, personally for me, it took me a while to get used to what sizes are themselves. And the sizes is the numbered aggregate. And the number aggregate is a classification given to a specific type of aggregate that can be used whether if it's for box culverts or concrete mix designs or asphalt, anything like that. This is the starting basis that an engineer would look at to determine, okay, if I want so much stability, or so much to be permeable, or if I use it in a concrete mix, what kind of stability am I looking for, or strength, not stability, I already covered stability, or strength do I want with like concrete. Stability is more for soils and asphalt. So these number designations, you would probably think, and for the longest time I always thought, okay, so the smaller the size, so if your number size is small, that means your aggregate's small. But as you can see, if we have number one aggregate, as people would say, or number one stone is what it's typically called in the industry. So everything here, they call it stone. So somebody's like, hey, I need a number 57 stone for this. Well, here's your 57 stone requirements, at least for this specific specification. But as you can see, number 57 stone, your largest particle size is really 1 inch. You have the 1.5 inch sieve here, but the only reason why you have that there is to see if anything is retaining on it. Because technically, if anything's retaining on it, then it's not 57 stone at that point. It's a different type of stone. So you kind of see where I'm getting at with this. Probably not. Probably lost everybody. But everybody's already like, good Lord, here we go, another TED Talk with Laz. And yeah, it's what, what do you expect? Come on, seriously. Hey, hold on. Let me top off my tea here. My motivation juice. There we go. All right, so technically, the bigger the number, the finer the aggregate. So if somebody said, hey, I need number 357 stone, this is 357 stone. As you can see, it's getting finer and finer as you go. But each type of stone is a little bit different, because if we do go back to the number 57 stone, we have a number 8 sieve. And a number 8 is technically smaller than a number 4. So if you remember from the last video that I touched base a little bit, so sieve sizes themselves, at least here in the United States, we have a U.S. standard sieve number to that, which obviously if it's in inches, then it's going to be reported in inches. Anywhere else around the world and whatnot will be in millimeters. I mean, technically, if you purchase any kind of sieve, it reports everything. It has your standard U.S. sieve size, your actual size openings, and things like that. Or, yeah, your actual size opening. And usually in millimeters, because, metric's more accurate. Sorry, America. It's true. And I live here. So, remember, your numbered sieve, the bigger the number, the smaller the openings are in the sieve itself. So, with a number 4 sieve, I believe that's, don't hold me to this, I believe a number 4 sieve is 4.75 millimeters big with the openings themselves. But why it has this number designation, if you remember from the last video, it indicates how many openings per square inch. So for this, you get 4 openings per square inch, and then here you get 8 openings per square inch. So think about that. The finer it gets, the bigger your number is going to be, because that means you have more openings on that sieve per square inch. So, when we talk about a number 200 sieve, that means there's 200 openings per square inch, where each opening is approximately not 0.75 microns big, not 0.75, 75 microns big. So it's small. It's very small. But, but that's kind of the general gist for this. So when it comes to specification sets or envelopes, mostly it's aggregates, sometimes soils. And all this is based on whatever the requirements are for a project. So an engineer, when they design this, they'll figure out, okay, hey, so for this you need to use this either this kind of stone or a material that meets, let's say if they say your material needs to meet ASTM D 448 number 7 stone, or size 7, size 7, the professional term. Everybody calls it numbered stone. So number 7 stone, number 87, number 86, number 89, that. So, if somebody says something like that, then whatever you have needs to meet these requirements. And that's it. If it deviates from any of these requirements, then you can't use that material. And, obviously for this you can set up your own, but I'm pretty sure it ain't going to let me do it anyways, because the thing's being weird for whatever reason. So, anyways. Okay, so I kind of covered all that. I think we should get down to the nitty-gritty here. I'm kind of used to having tabs here. Oh wow, so you actually have to pick a set. Interesting. I'll just say no set. Okay, there we go. That helps. Alright, so here we go. Here's the goodies and whatnot. So now this is where we're going to enter in our data from our actual sieve test. So for what I'm going to be entering in, the sample size is roughly about 100 grams big, and this data is from a proficiency sample that's technically a hydrometer, but with no hydrometer. So there's no particles that are finer. So we're not measuring the particles that's finer than number 200 sieve, and that's all a hydrometer tells you. The hydrometer just says how much silts to clays is actually in the material before you actually wash it. That's all hydrometer test really is. So okay, so we have our initial and whatnot. So our dry sample and tare, and then tare itself. Yeah, I know it's not a valid number. I'm trying to be cool or something. Okay, so we're going to enter in our dry sample plus our tare. So for this here, we had 149.31 grams. So this is in grams. And in here you can enter in your tare weight if you choose to, which for this has our dry sample and tare. So technically if you want to get around the tare part, then you can subtract your tare from your sample just to get your sample, and then you can probably leave your tare as 0. I don't think it'll let you leave it as blank. Yeah, it won't. You got to enter in something, but it's fine because this has also the tare weight too. So our tare weight for this sample is 50.76 grams. Okay, cool. So then after that we have our afterwash. So our afterwash is what was the weight of our material after the wash. So let me see here. Where is that value? Let's see, that's the air dry. Ah, okay. Yeah. So this is 59.34 grams. Oh yeah, and I guess I'll enter in the tare weight. 50.76. Okay, perfect. All right, so now we're just going to enter in our sieve sizes and whatnot. Take a sip of tea here. So, you know what that means? I'm going to be talking a lot. Excuse me. Okay, so the rule of thumb when it comes to a grain size analysis or distribution, gradation, however you want to call this, you must have a sieve that has 100% passing. So you can never have a sieve that has a weight to it and then going from there. Your cumulative weight must be 0 to start. Otherwise, your curve isn't going to work correctly. And maybe I shouldn't say your curve isn't going to work correctly. Your distribution curve should work just fine. The main question is going to be if, when another engineer is going to look at this report, or a client, or whoever is going to look at this report, and if they just see, because technically I'll have weight retained on the number 10 sieve. But the thing here is that if you start with that, then it opens the can of worms of, okay, well, what is the smallest size on this sieve? Where's our 100% passing? Because you could have cobbles or boulders, or did you have material retained on the 1 inch, the 3/4, the 3.5 inch? It opens that can of worms where people are just going to ask questions. Okay, well, where did it start and whatnot? And where that really comes into play, especially, is if you're doing aggregates that have those sieve envelopes that I talked about. Because remember, some of those said, depending on the your aggregate size, okay, well, 100% needs to pass the 1.5 inches. So if you start off with the 1 inch, hey, you have material retained. Okay, well, that's fine. But did you have any rock retained on anything greater than 1 inches? Because technically, you can have material retained on a 2-inch sieve, everything passes the 1.5-inch sieve, and then everything else is good, following your requirements. But technically, it failed because you had material greater than 1.5 inches. So that's why that's really important to report that. Okay, so okay, I'm just kind of getting my bearings a little bit, because this program is definitely a little bit more different than what I'm used to. Number 10. Because remember, I'm doing a hydrometer with no hydrometer. So to give you some background here, as if I haven't given enough background already. Yeah, no, I meant 100. Number 140 and then number 200. There we go. So now we got all of our sieves. So technically, kind of like what I was talking about, you have a separation sieve. So for this sample that I do have material retained on a number 10 and greater. And your separation sieve is technically an auxiliary sieve analysis that you're going to do. So this is actually going to be a very interesting part, because this is set up much more differently than I have expected to see. And I think I know. I think I know how to make this work, since there's an after split, but I don't know exactly if it's going to know when that is, but I think it might. Or I wonder if all this data should be over here for the after split and then my main data should be over here. I think we might switch these around real quick because technically I do have more data because I have the total sample weight, because technically for a hydrometer it's a subsample of your main sample, where a hydrometer test you only need 100 grams. It really depends on the material type. I know, going down a rabbit hole here. Bear with me on this. So it really depends on the material type itself, where technically if it's silts or clays you only need 50-ish grams to run your test. But if it's sandy, then 100 grams will suffice. And they come up with all these weights and stuff because it's based on volumes that the test is going to be performed in, because technically your hydrometer test is performed in a 100 milliliter graduated cylinder. So, and then your hydrometer, granted there's so many different types of hydrometers out there, but you can only use 2 specific types of hydrometers for this test. You can either use the H151 or the H152 models. It doesn't matter what brand it is, it's just those are the models for that you use, and each one gets distributed differently when you introduce it to the sample. And I know all this talking and stuff is really boring, and I'll bet if there's enough people interested, I'll bet they would like to see how this is performed and whatnot, and maybe we'll go down that avenue another time, because I don't think there's really a lot of interest in this. Can't even do nothing with the after split, so that's cool, that's great. I wonder something actually. Well, that's what it's going to look like in the end. Let me say, I'm curious to see, so if I say hydrometer analysis performed, I wonder if this is going to open up, oh wow, mechanical data and curve data, interesting. Okay, does that open that up? It doesn't, and I'm pretty sure, hey, hold on, let's check this. I'm pretty sure this is, this is like going to be all the specific, good lord, all these boxes are all connected together. Good night. Oh my goodness, I'm pretty sure it's just because of the graphical settings. I mean, it has everything you need to do it, but I'd have to have automatic temperature correction. Oh, okay, cool. So it has that, but I'm pretty sure if I say no, that's when it'll let me type it in, right? Yeah, okay. Well, automatic temperature. How would you? Interesting. It was a different time back then. You use hygroscopic moisture, yeah. Huh. I might have not enough data to calculate it on basis of weight. Yeah, I know. I just wanted to see. There you go. Abort. Abort mission. Okay. Yeah, so that's definitely not going to help us for sure. Mechanical data calculated, huh? We're sure you want to do this? No. Okay. So that is where actually, yeah. What does that do? If you didn't perform an actual analysis, see now I'm curious. So can you do anything? Object was unloaded. Ooh, it didn't like that. It didn't like that at all. This is very interesting. So this is really going to get messed up because I don't know how to enter in a separator sieve. Unfortunately, I don't know how to enter in a separator sieve from here. Ooh, wait, there's a split sample function. Actually, hold on. I think what I'm going to do is I think I'm going to do exactly what I talked about before exiting out and doing everything. And then I'm going to see what the split sample function is going to do, because I wonder if I can put in all my data, select wherever I can say split sample, and then I can put in my other data that's part of my split sample. Easy, right? I mean, all right, so let's try this again. So 149.31, our tare weight is 50.76, our afterwash is 59.34, and then 50.76 because it's from the same tare. All right, so let's try this again. So let's do number 4, number 10, number 20, number 40, number 60, number 100, number 140, and then number 200. Okay, and before you guys start asking questions and stuff, because, you know, boy, the questions are rolling in, let me tell you. So a sieve set is determined either by the engineer or by the laboratory themselves for however that they want to sieve the material. So technically for a lot of specifications, like if we did do the full AASHTO T88 hydrometer and whatnot, technically your only sieve requirements are number 10, number 40, and number 200. I was close, I just needed to add the 0. So number 10, number 40, and 200. Where technically you could do a sieve on just those 3 sieves and then there you go. But the thing is, you know, if you're actually trying to get a good distribution, distribution curve, you want to use as many sieves as possible so it can distribute better on the curve. That's the idea. Okay, so anyways, let's actually enter in all of our weights. Oh cool, this is interferently. Alright, so we're going to say 0, 15.87, 2.79. See, this is where things are going to get weird, because our number 10 is our separator. See, now that's opened up. I think this is where things are going to get fixed. 6.29, 7.85, 8.55, 9.01, and then there you go. So technically, for your sieve analysis, it's going to be percent finer, and it should be a descending number. So seeing this here, this is a big problem, because you can't go 100 and then 80 and then 90 again. It's okay if it goes 100 then 80, or like how it's 83.9, but technically your next value cannot be greater than your last value. It either needs to be the same or less. So this is what made my heart skip a beat, but I think what we could do, if this is going to work right, so I'm going to select number 10, and what if I say split sample? Oh, on number 4. That's not what I wanted though. I don't want to split it on number 4. I want to do number 10. I know, I needed it on number 10. Okay, that's got to be a setting. Oh yeah, help ain't gonna help me. You kidding me? Use the help function. No. I ain't using no damn help function. I know what I'm doing. As I fumble around a lot. Anyways, okay, that sucks because that really needs to be number 10 because I don't think this is going to work properly. So technically, and I feel like maybe we can check the settings and maybe this will be fixed. But that's weird because I thought the option was automatically set to 10 when we looked at it before, but I don't know. I mean, because the settings aren't playing ball right now for whatever weird reason too. So anyways, the original sample that we had before we processed it over a number 10 for me, because our hydrometer, it's like I said, you have an option to pick between a number 4 or a number 10 sieve, and for me I usually pick a number 10. So anything passing the number 10 would be my air quotes hydrometer. For this, my sieve analysis test, my hydrometer with no hydrometer. That's my favorite thing to say. There's nothing better when I want a hydrometer test with no hydrometer with that test. Cool. And that pretty much means you do everything but the hydrometer portion of the test. For those people that are scratching their heads, if you already haven't logged off or clicked off the video or left the stream or whatever. All right, so the original sample size is 363.7. Yeah, that's our original weight. And then I'm just going to say 0. So did that actually fix that? Nope, it just messed things up even further. Made everything 99% passing. Well, that don't work right. Split on number 4. So why do you have... Why is this in... Yeah, no, because that's not right. What we had before was correct, except for here, where we had the 80-something, because technically it was basing it off this weight here. Unless if it really is the other way around, actually. Let's flip it. Let's flip it. Let's do 363.70 at 0. That wasn't 0. What the... Oh, yeah. I'm used to everything like, oh, man, it's highlighted. All right, our afterwash, we'll keep that. Okay, see, now that makes sense. 10. Why is there 2 10s? Weird. Okay, so, okay. I'll bet it's exactly as I thought it was going to be. 149.31. And then this is 50.76. No, it's still not doing it right. Wow. So how would you do a split sample? All right, let's see. This probably ain't going to help. Splitting the sample. Okay, split sample gradations use a smaller sample size for part of the gradation. Yes, kind of like what we did here. So first enter all the data of the sieves that utilize the entire sample. Okay, after entering the data for the last sieve that utilized the entire sample, press enter to proceed to the next grid line and select split sample menu option. The program will respond by requesting the weights of the sample tare. Okay, yes. And split sample. Additionally, if the cumulative method was selected, the program will request the tare weight in the pan used to accumulate the weight of the samples. Press enter after entering the last weight. Will return the data entry prompt to the grid. Continue entering the values that utilize the smaller sample. Okay, so, okay, yeah, so I think this is how this is here. It's just that math is not right at all. Because it's only making this number that big because technically it's looking at this saying, okay, so you originally had 363.70 grams and now you're down to like 7.85, which that's 99.8% passing that particular sieve. But the thing is that technically we started with a sample this big, then we made it into a subsample, which is this size for our hydrometer sample, our air quote hydrometer sample. And then technically if you have anything that's coarser than whatever size sieve that you pick, whether it's number 4 or number 10, that's where that portion would be technically an auxiliary sieve set, which that's why this number is bigger than everything else, because 15.87 grams of this was from this 363.70. So out of that 363.70 grams of material, only 15.87 grams was retained on the number 10 sieve. So everything else past that, but I don't need to test like a 347.8 gram sample when all I need is 100 grams of that. So that's why this is like this. Wow. So this is a really, like, the newer versions of this handle this so much better. So much better. Because this is, wow, this is far from right. Wow, this is really far from right now. That's a problem. Good thing I'm not reporting this. I know I'm probably doing something wrong. Obviously, I'm doing something wrong. But why? Yeah, yikes. But this is technically, I'm glad I picked something hard like this, because I didn't think about this. I could have just picked like a basic aggregate sample where, this could have been, hell, let's just say, whoops. Wow, okay, well, just whatever. It could be something like that. And as you can see, it goes in ascending order for your cumulative weight, and then it's going to go in descending order for your percent finer. That's technically how a sieve analysis, grain size analysis, gradation, the test with many names works. So, I could have picked something simple like that, but that's one reason why I like Geosystems, at least version 5. I think I'm using version 5 at work, which I think, no, maybe it's version 4. I think version 5 is the newest one that's out, or they could be getting ready to release 6. I don't know. I don't really keep up with that software portion, because if it works, then it's good. It's good. It's good, right? It's good, right? You'll nod with me. Agree? Sure. Yeah. Perhaps. Maybe. Anyways, so how? I wonder if I can fix this. So even with the help file, which was helpful, I did figure it out on my own. But the problem is why is this happening? So it's still looking at this, and then it's looking at this. See, now the split sample function's gone. Probably because I have data here and whatnot. And of course, for the cumulative tare, that's if it's usually 0, because we'll tare the tare. So in other words, we'll zero out the tare as we add our weights. Because technically, we could use that tare right there, so that tare weight. But technically, instead of entering in this number, it would be this plus your tare weight if you put in that tare in there, which I don't know a lot of people that do that. Usually they will zero their tare or tare their tare, because tare is another word for zeroing, as if this can't get any more confusing. You're following along, right? So wow. Yeah, I'm kind of stumped. I mean, it does what it does, but like if you have a hydrometer, I feel like you're kind of fucked. Back in the day, I mean, I would have rather hand calculated and plotted it at this point. Man, how technology has gotten better over the years, or software. Huh. That's really weird. Here we go. A smaller sieve has a percent finer larger than the percent finer calculated for a larger sieve. This is not allowed. So I know what you're thinking. What does that mean? It's this. It's exactly this right here. It's exactly what I talked about. You can't do, it can't go 99.6 to 99.9. That's not how that works. Oh, good Lord. Well, this sucks because I think what I'm going to have to do is I think I'm going to have to get rid of my number 10 or just say my number 10's at 100%, even though it's not. So I think that's what I'm going to have to do to correct this. Unless if I can figure this out, but I don't think I will. I know. Everything's, I need a number. How about 0? 0's a good number. Damn, so I guess once when you turn on split sample, it just, that's it. It's a one and done. You can't do nothing. You're screwed. It makes me wonder, do you really need the afterwash weight? I mean, it's just a way to figure out, like, your 200 sieve is, you know, if you don't want to do a gradation. Oh, good Lord! Of course, it's like sometimes it works and sometimes it doesn't. I don't understand. All right, let's do the 149.31, and let's do the 50.76. There we go. So I think what I'm going to have to do for this one is I think I'm just going to say 0% passing for this to work. Which sucks because this should just work, but it's not for some. I can't. But even when I say split on number 4, it's still not doing it right. It's still not doing it right. So it's just weird. I know. Just 0. 0.00. There you go. I know this will work. Good enough. I mean, thanks. Okay, so now here's our distribution curve. Here it is. So this is the whole distribution part right here. So this determines your particles and where they are at and whatnot. So as you can see down here, this is grain. This is your grain diameter, so your actual size in millimeters, and this is your percent finer. So, you know, this top part being 100%, you know, here's our number 4, here's our number 10, 20, 40, 60, 100, 140, 200. And as you can see right here, you got little lines. Well, I say little lines, but you got little tick lines, which technically go all the way through down to the bottom. And here's the thing. So as you can see here with our number 4, kind of like what I've been talking about for a while, your number 4 is your final separator for it going into sands. Okay, so as you can see here, you have gravel here going up and whatnot, all the way up to 100 millimeters, and or greater if you wanted to, if you have anything greater than 100 millimeters. And you know, your gravel is anything greater than number 4. Than your number 4 sieve. So your sieve opening being 4.75 millimeters with your opening, which, because there's 10 millimeters, so here's 1, so what, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah. So this, I think 10's here. It's very deceiving. At least I would say 10 is here. I'll bet it's here or something, because if it's 4.75, it's here. So this would be 4, 3, 2, 1. I don't know. This graph's a little. It's dated. It's not how it used to be. It's okay. I'm probably making myself into a fool anyways. It's cool. It's fine. I know what I'm doing. Believe me or not, it's cool. Anyways, so kind of like what I was talking about before. So anything that's greater than your number 4 sieve, because these are all of our point sieves, kind of like how I discussed. So this is our number 4, and then here's our number 200 sieve. So technically, anything past gravel is considered cobbles or boulders. Is the general synopsis that engineers will say, but usually, for most cases and whatnot, usually engineers don't really care about sizes that big, which is why that's like you got space for it if it is there to kind of indicate like, hey, I need number 57 gravel to be used. Okay, so then this spot would be utilized more here than over here. Unless if they did like a 200 wash, then it would be over here on this side somewhere as the curve goes. But, if they only wanted number 57 stone, okay, well, why do I have these boulders or cobbles? I need gravel, not boulders and cobbles, It's not too often that they need anything bigger than that for engineering purposes, unless if it's the only thing I can think of, and I wouldn't even say I'm pretty sure it's utilized more often here where I'm at in the great state of Florida, but like beach restoration. We don't have a lot of rocky beaches. It's usually sandy beaches, but I'm pretty sure if you wanted like barriers and things like that to help prevent the erosion, I mean, the bigger size the rock or the boulder, the better it's going to be to break that wave before it hits the beach and erodes it away. But I never really dealt with any kind of projects that were like that. But that's why I don't want to just throw that out. It is still a thing. That's why it's still described it even in the settings. It's just, it's not widely used, which is why you have this for your distribution curve. You have your gravel, sand, silt, and clay. So for what we worked with, cool, thanks for hiding my inactive icons. How do I know? I don't know how to press this arrow button. So now for the sample that we worked with is considered sand, even though it's more like a clay. If this was more like a sand, you would see a curve going downward like this, going all the way down to 200 and whatnot. So if it was more of a sandy material, this is more of a clay material, which is why everything has been passing around. It's 90% or greater, as you can see, because here's our 90% line. So from our number 4 sieve all the way down to our number 200 sieve, this is considered our sand portion here. And I hate to jump around, but technically usually gravel ends around 3.5 inches. So that's where that point is roughly. It's either 3.5, some people do 6 inches. It's an adjustable setting that you can do, but typically it's somewhere around there is where gravel ends, but I hate to jump around like that. So then you have your silts and clays right here. So technically this is the material that's passing your 200, which typically speaking, when you do a sieve analysis, most of the time, well, I can tell you already, if they want a 200 on it, all of the time you will wash it. You will never do a sieve analysis on material that needs a 200 sieve and not wash it. So, because if you don't wash it, you can't get all the fines and particles out of the material, where you may not get as much passing your 200 sieve if you just sieved it as it was. That's the whole idea of that. So technically, you would wash this before you would sieve it, which that's exactly what happened with this sample that I've entered in here. So just to kind of recap overall, I had an initial sample size of 363 grams that I split 100 grams of that into my air quote hydrometer sample that was washed instead of a hydrometer performed, which the only other steps that you would do if it's a hydrometer is you would let it sit in a solution of sodium hexametaphosphate. I know that's an easy word to remember. So you would let it sit in that solution for 12 hours, and then you would start your test, putting it in your graduated cylinder, adding deionized water to it till you get up to your 1,000 mil mark, and then you'd start your hydrometer tests for the most part. I'm skipping a lot of steps here to simplify this, by the way. So, if you're an engineering student thinking that you can learn something from this, you can, but this isn't going to be a step-by-step guide here. We're checking out the program. I'm just generally explaining to people how this works, because I don't know where my audience is, if I even have an audience. It's okay if I don't. I like talking into the nothingness, in the void. It makes me feel good. Makes me feel powerful. Talk about grains and sizes. Anyway, so with that hydrometer portion, when you do that, the way how the test works is you would put a hydrometer, and that's what the device is called. It's called a hydrometer. So you put the hydrometer in your sample / sodium hexametaphosphate solution, and then you would wait for it to stabilize, and then you would take a reading on it. And overall, just to kind of explain what a hydrometer is, a hydrometer it mostly just determines what your specific gravity of that material is at that point in time. Technically, where hydrometers get used the most is breweries, places that make alcohol. You can use a hydrometer to tell your alcohol content because of the specific gravity of the beer or the ale, the alcohol itself. Because technically, water itself, and I'm only pausing here because this is going to be another Laz rabbit hole we're going down right now. So technically, the specific gravity of water is 1, but your specific gravity of water is at 1 if it's at 77 degrees Fahrenheit. Then your specific gravity is at 1. The temperature greatly affects what the specific gravity is of your liquids. So, just generally speaking, your specific gravity is at 1 for water. It usually is. If it's colder or hotter is where you would see the difference. Your density of your water becomes greater as it gets colder, which, if you think about it here, ice. As it gets colder, your density will become more, hence your specific gravity will become higher. Unlike if your water is warmer or hotter, your specific gravity will be lower because the I don't want to say the chemical change of it turning into steam, but it's also all the molecules and particles moving around. Come on, this is like I don't even want to say grade school science, but this is pretty much like grade school science. Like, this was the thing where they had the beautiful looking graphics and stuff, that showed look at all those red dots moving everywhere to indicate hot water as it transforms into steam, as it becomes a gas, a vapor. I know, I'm digging in way too deep. But anyways, so back to the hydrometer test, right? Just, you guys are taking notes, right? Even though I told everybody not to, make sure you're taking notes. There's going to be a pop quiz or something if I remember to do that. So, so your hydrometer test for soils specifically, it's going to determine your silts to clay. And that's pretty much material that is finer than your number 200 sieve, which, remember, your number 200 sieve has openings that are 75 microns big. So this is everything that is smaller than 75 microns. It's what's being determined for the rest of this curve here, which, unfortunately, for how this program's kind of operating, I don't think I can show a hydrometer, because I don't think it's going to plot correctly. And I don't know if I actually have a final report of that, as well as if the final report is anything that is a proficiency sample, preferably, instead of job details and whatnot. Because, while ultimately in the end, anything that gets built, at least here in the United States, becomes public record in the end for whatever that is involved with it. During its building phases and whatnot, or if they signed a almost said non-compete clause, a disclosure clause, then I can't cover any of that. This is the reason why I'm just covering proficiency samples with this program. So that's why, with proficiency samples, this is testing that's been done by multiple people, either, well, mostly all around my state primarily, but also around the country, depending on where the data is from, or where you get your proficiency sample from, or who is participating in the program, because it's optional to participate. I say it's optional, but technically it's not. So I don't know if I'll show that, as well as if I even have one, because we don't do hydrometers often, because Florida doesn't have a lot of silts and clays. And even when we do, most of the time, they just typically indicate that it's a non-suitable material. So it just gets removed anyway. So people just don't think about it. Unless it's really deep, then they'll work with it and figure out how to engineer with it or around it. So technically with this curve, as well, not with this curve, but with this graph here, this chart, as you can see, we got lines here to here where, once when we're about halfway, like this is probably .05 maybe, because it only gets more accurate as you go. So about here, this portion here, wherever your distribution curve is, indicates your percentage of silts, because your hydrometer tells you what is your silts to clay that is in your actual sample itself. So the way to think about this is the density of the particles themselves. So, we already know, just everyday people, I mean, I'm hoping somebody has touched grass or dirt in their life. I'm hoping. But the thing is we all know that rock is heavier than sand too, right? One particle of sand, not like a handful of sand, it can vary. But we all know that, right? So obviously your particle density is what this test really refers to, the actual hydrometer portion. So everything past this is all hydrometer portion. Your typical, hey, I just want a sieve analysis on soils, ends here. It always ends right there. Maybe you'll have some gravel, maybe you won't. This is why you're doing a grain size distribution or particle size analysis, however you want to call it. So the thing is with silts are more dense than clay. So when you do your hydrometer test, because technically you're going to suspend all your particles before you put your hydrometer in. See, that's some of those parts that I was missing out on before when I was skipping around describing the test. So your silt particles are going to fall faster in your solution than your clay particles. So like let's say if we're, I don't know, here or somewhere. So let's say we're here on the 200 mark, give or take. I think I'm past the 200 mark. There's like the 200 mark. I mean, who really cares, right? I mean, Jesus, you're being more critical than you need to be, Laz, right? So let's say, okay, this is where our 200. So when we do our hydrometer portion, if we look at the mouse, it will kind of gradually go down, like so. Sometimes if it's pretty sandy, it will kind of stay in a straight-ish kind of line. But if it's really silty or clay, it will kind of somewhat gradually go down, but it's not going to be like that. It just gradually settles. And the idea is that with your hydrometer tests, you're taking a hydrometer reading at timed intervals. So, you might take one at 1 minute or 30 seconds. If somebody's a monster, 30 seconds, that's so hard to do. 1 minute's not easy too, but you might have like maybe 30 seconds, 1 minute, 2 minutes, 5 minutes, 15 minutes. So you're taking these readings all the way until usually people are satisfied after 24 hours how much, what your material is going to be. Because granted, you can run the tests indefinitely, and ultimately in the end, all your particles will settle to the bottom of your graduated cylinder, and then now you're just measuring your sodium hexametaphosphate, which the thing is since it's a chemical, that does have a specific gravity to it, so you will have a reading on it. So most of the hydrometers that we use in our industry doesn't have, or it doesn't really require it to indicate the specific gravity on it. It just has to have a reading number on it. So usually it's like 0 to like 20 to 50 or something like that. Obviously, it's been a while since I've done a hydrometer test, probably close to a year. I mean, proficiency samples, I do at least once a year. But I can't remember all the numbers that are on that thing. But they're whole numbers. They're whole numbers. Maybe there will be a tick mark in between the whole numbers to indicate a half. Most of the time they don't. Which I like to emphasize on that point here for any kind of lab person that might come across this. Remember, guys, if there's no tick mark in between your readings, so if you're between 4 and 5 and it's in between 4 and 5, you can't say 4.5 unless there's an actual tick mark on there that indicates that's your half mark. And I get it. The accuracy would be, well, it was in between those two, but was it actually 4.5 or not? There's no tick mark to determine that. Okay? And the manufacturer makes that the way it is. So stop doing that. That's not accurate. Okay? You're between 4 and 5, you go to the nearest whole number, unless there are graduated marks in between that. Okay? For any lab person that might be checking this out that thinks that that's okay, let me tell you how not okay that is. Because then it's up for interpretation. Okay? Because if you get something wrong with your test, and I'm not saying this as an experience thing that I dealt with before, it's more so if somebody really wants to investigate your work and you said you did 4.5, and they look at your equipment and you don't have a 4.5 mark or any half marks anywhere on that hydrometer, well, was it at half or was it 3/4? Was it a quarter? You can't prove that because you're eyeballing it. That's why you go to the nearest whole number. Okay, rant over for that, but please, I can't stress that enough. Use the equipment as intended. I know it's tempting, so tempting. Hey, it was about halfway, so I'm just going to say 4.5 or 4.25 or something. But no, if it's only in whole numbers, to the nearest whole number. If it's between 4 to 5, it's 4. Okay? Between 5 to 6, it's 5. Okay, ran over for sure now. I know, I'm a little spicy about that, huh? I just can't stand it. But, I mean, so like I said, technically with a hydrometer, it would have a curve going, slightly down. It wouldn't be a steep, sharp drop. Okay, so let's check out the other functions and whatnot of the software. I know, I only spent 15 minutes talking? I mean, technically this whole video I'm going to be talking and whatnot, but, Alright, taking another sip of tea here. Alright, let's see all these other functions and whatnot. So we got shaping, add shaping point, delete shaping point, return to original. So what is shaping points? So is this where I can just add points in general? Oh wow, yeah. Ooh. Actually, let's return an original curve. Hey, that's actually kind of good because, so let's pretend we did do a hydrometer. I'm going to try my best to kind of draw how it's going to go, sort of. Let's see, replace data point with shaping point. No, I don't want to do that. So let's say we did, I don't know, like one here, one there, there. I'm just spitballing here. I wonder if it'll actually. Well, I'm sure it'll report it. It's just I don't know. Ooh. That doesn't technically go up like that unless you took a bad reading. Good lord, how many points do we do? Usually I don't do this many points for a hydrometer because technically each point here that I'm adding, that would be your time and reading. And every time when you take a reading, you also take a temperature. Because specific gravity. Oh, I can't add any more points. Ooh, I went over my point limit. Okay, whatever. I mean, so technically I should have spread that out a little more, but that's all right. So technically, if we did a hydrometer, it would be something like that. I guess I should have just did that instead of, talk the whole time. What are points? Okay, I think report will show points only. So, yeah, so points only is that without the line itself. Usually people want to see the curve itself more than the points. The points just indicate, okay, about where is it at in millimeters. Well, we do have a 0.5 reading because I put something there. Yeah, I had to make it over there to make it do whatever. Yeah, but this looks about right, where it is, So, I mean, granted, this is really off because, I just did all these points, but that's kind of cool. It still did try to calculate the hydrometer with where I tried to put the points, but, I just didn't do a good enough job. Let's see, what's the calculator? Add millimeters, add mm for millimeter sizes. Oh, cool. So you can do that. What could I put? What if I did? There we go. 99.8, which sounds right. That's, the 200 sieve, by the way. Okay, well, that's cool. I guess if you wanted to know specific points, that's kind of weird. Huh, that's really weird. Why would do that? Weird. Okay, anyways, we're just going to return it back to the original curve. As you can see, we don't have a 270 sieve, so wham bam, thank you ma'am. No finest modulus, that's what FM is. No D10 because this is really clay stuff. And all these are different values. That is a formula that's calculated depending on your actual particle sizes that is passing and whatnot. So, cool. So, is there any way? See, that's what's weird too, because even we look here, hydrometer separation sieve 10. Oh, minimum gravel size. I'll bet this is where I was supposed to do that. Report coarse, medium gravel. That just defaulted. Ooh, any changes made to the hydrometer separation sieve, minimum gravel size, fine sizes, and silt and clay divisions will affect only this test. These settings may be changed to affect new tests going to option screen. Okay. The setup requires the distribution curve to be reviewed on screen. It's the same. Okay, so See, it still says separation on number 4 though. See, I don't think it's gonna work. I don't think it did anything, to be honest. No, it still has set to 10. Huh. Weird. Oh yeah, different report formats. Let's see, so I'm guessing the curve thing is just what that was, so let's just do, ooh, no, not 5 tests per page. 3 curve report, basic report, ASHTO classification. Yeah, printing for letterhead. Yeah, yeah. Okay, so I wonder, whoops. Yeah, curve. Huh. Can I don't know why I clicked help. Help isn't going to help me. Wow, this is so basic, man. Oh, good God. Huh, so oh, let's hit quit. And is there any way I can just view a report? Project data options. Export. Oh yeah, no, that's just actual exporting of. Would it be through here? See, I think this. Oh wow, print to printer. I know. I should have set up like a PDF tool or something. I know. I wish I could view the report. I mean, like what the final report was going to look like, but I don't. Oh, here we go. I'll bet it's going to say no printer. Can I? Oh yeah, preview report. There we go. Preview reports on screen. Hey, there we go. I figured it out again. Oh, good lord, I can't zoom in. Oh, good night. Yeah, so technically this is what a distribution curve looks like, and this, ooh, wow, yeah. So, at least for a final report, this is what it generally looks like, at least for Geosystems, which this is kind of how I've always looked like over the years and whatnot. Oh, hard copy report. Oh, okay, that just means print. Why don't you just call it print? Man, times were different. I don't know what print means. You mean hard copy reports? Yes, hard copy reports. Oh my god. Select all reports for printing, auto combine. That's cool. Alright, well that kind of yeah. So it should have been able to do what I wanted it to do, but I couldn't have it do what I needed it to do. That kind of sucks. So unfortunately, I had to fudge my data, which is not a smart thing to do, and say that I had 100% passing on my number 10 sieve, which is very, very wrong to do, by the way. Especially when it comes to a grain size analysis or particle size distribution. Usually people call it particle size distribution if it's a hydrometer and whatnot, but especially when you do a hydrometer test, you account for every particle that is in that sample, big or small or non-existent. Everything in that sample needs to be accounted for the report, so they know the engineer or the contractor or whatever the intended use is going to be, because if they're asking for a hydrometer, it's extremely important because they need to know all that data, especially the clays and silts. That's really the most important thing, but you don't want to say, oh, well, it was a very clay thing. Okay, but if it was a very clay thing with, like, I don't know, crushed shell or rock or something, that's kind of important to include in there, because if they're looking for stability, well, technically that clay has the stability there with, the aggregates or shell or whatever that's in there. But if you don't include that in the report, well, they'll never know that, and that's why particle distribution has the curve. You need everything in there and whatnot. So, actually, I just want to see real quick. Let's check out the AASHTO classification. 90.9, yep, so, A762 was a highly organic-y. And if we check out the USCS classification, it's saying it's CL, so it's lean clay, which I believe for sure. And of course, we don't have any of these other ones because we don't have, this is more of a sands thing. This is like coarser going to finer for sands, and it's like I said, that's just your formula and whatnot to do that. Okay, that's it. Now I had enough fun. Okay. All right, ladies and gentlemen, I think that ends my TED Talk for this time. Hopefully you enjoyed it. Actually, I don't think anybody's on the stream. I don't think there is. I know I got messages and stuff, but I think that's just, for my friends and things like that. That'll get to shortly and whatnot. So, hopefully you guys enjoyed this. I would have went through the installation process, but we went through that from the last video, so that's why we just got deep into it. There's still plenty more to cover and go, so this series ain't ending anytime soon. But hopefully you enjoyed it. If you're sleeping, then I did a good job while watching this video. Cool. If you made it to the end of the video, cool. I hope this was really entertaining and whatnot. I know I wouldn't say I have dry humor, but I know sometimes I get a little bit more technical than I need to, but it really requires explanation for what is going on, is my whole point about that. So that's why a lot of it's a TED Talk. Other than that, obviously if I shorten it, this would probably be, I don't know, a 10-minute video, if that, with editing and doing all that stuff. But I'm a horrible editor, and I ain't gonna hire one because I ain't made of money, and I enjoy editing too by not editing. Giggle, giggle. Anyways, okay, enough of me blabbering. I hope you guys enjoyed this. I have fun doing these. That's the whole idea. And obviously, if you got questions or anything, leave them in the comments. Let me know. I will gladly answer any of this stuff. I've been doing this for 18 years now, and it's like I said, I just thought this would be a fun little share thing to do. All right. Bye. Until next time.